Howdy, everybody. This week we are looking at volume. So today we're going to take a look at this lesson and work through it together. Volume of a rectangular prism visually. I guess we'll just play this video and see what it says. How many cubes are currently in the prism? It's going to be 10 cubes in the prism because it's one for each of the height, or you could just count them. Boom. We're going to play it again. How many cubes are currently in the prism? It's 10, but times 6, so it's going to be 60 cubes. Now we had 60 times 2 times 3 times 4. There are 240 cubes now in the prism, and that's going to be the entire volume. When you fill it up, it's going to be length times width times depth. I'm not going to go through that 5 times here because I trust y'all to be able to do this, and the animation takes a little bit of time. So we're going to go ahead and just check it out ourselves. A cube has an edge length of 9 meters. What is its volume in cubic meters? Calculators can be our friends here. Now, when you raise something to the second power, it's called squaring it. When you raise it to the third power, it's called cubing it. And that means whenever you find the volume of a cube, you're actually just raising the side length to the third power. And that's actually why they call it cubing. So 9 to the third is 729. That's going to be its volume. So whenever you have 3 dimensions, so the cube, you get that volume because that means it's the same on all sides. So 9 wide, 9 deep, and 9 tall. So that means you're just going to multiply 9 by 9 by 9 because generally speaking, the volume of a rectangular prism, which means kind of like a rectangle in 3 dimensions, is going to be length times width times depth, as the animation said. So 17 times 15 times 17 again. 4335 is the answer that we get, and it is the right answer that we get. Again, when you see cube, you can just raise your number to the third power, which is the same as multiplying it by itself 3 times. So 15 times 9 and 7. Boom, these are actually just kind of pre-cake here. 945. Nailed it. We're going to do the same thing. You're going to get 480. Got it. We're just going to move on to the next section. We're already that much of the way done. Now, the volume of a cylinder is going to be a little different than its surface area. Rather than worrying about the base and then getting the height by doing circumference times height, by lateral surface area, we're instead just going to take the area of the base and multiply it by the height. For kind of a similar reason. It's like it's going to take up this much space in 2 dimensions multiplied by its duration, so to speak, in the third dimension. So that means we're going to do pi times 9 squared, because that's going to be our r. So pi r squared. And then we're going to multiply it by 4 for the height. We get 1017.87. That rounds to 9. What we need. As we do this volume, we're just going to change those things. Height is going to be the thing we don't square. Radius is going to be the thing we do square, but it says base diameter. So we want to actually divide that in half. So instead of 12 squared, we want 6 squared, because diameter literally just means twice the radius. So 1470.26 rounds to 3. This time it is radius, so we don't need to cut anything in half. We're going to just use it as is, and we square it. This is kind of convenient because when we square 5 and multiply by 4, I don't know if y'all would recognize this number yet, this early in geometry, but the 3.1415926 more things is actually pi. So when we see 314.15925, we end up getting 100 times pi. So pi times 5 squared times 4 is just going to be 314. 2. Kind of hate rounding pi that way, but that's what we got. It's because 5 times 5 times 4 is 100. Okay, so 6 is going to be that height. The diameter is 20, then the radius is? Right, 10. Nearest tenths place, the 0.95 would round out to just 1885. I mean, it's not the worst thing in the world. So we get a 2 from here. Diameter is 4 inches, so radius is 2 inches. Nailed it with that 25.1. Sweet. Let's hop into the next section. The volume of a sphere. So this one's going to be a little bit different. So sphere has kind of an interesting volume. I'm just going to have to tell you this one. It's not quite as intuitive as the rest. You know what? I'm actually like, I know what it is, and it's not too hard to memorize, but it's not quite as obvious as like the rectangular prism being length times width times depth. I actually took a brief trip to Google for this one to see if I could find an intuitive way to explain this without kind of overwhelming y'all. And apparently, all the explanations for why the volume of the sphere is what it is kind of goes beyond what I'm going to be teaching you right now. So I'm just going to tell you the formula and not worry about the method and the why. Unfortunately, because I mean, I kind of like having the why things are true aspect, but it's not going to be terribly convenient in this particular case. So what we're going to do is, I'm just telling you that the volume of a sphere is, oh, by the way, if you haven't heard the word sphere before, that's just a circle in 3 dimensions, like a ball. So we got 4/3 times pi r cubed. Now, personally, if I didn't know the formula and I was just going to come up with it knowing how a circle works, I would have just said probably pi r cubed or something. Now, unfortunately, it's 4/3 times pi r cubed, and I'm not really sure why, aside from that's just kind of how it is. I'll look into it sometime. Either way, we're going to go ahead and just place the radius into this formula. Diameter is 6, radius is 3. So 113.09 rounds to 1. Hemisphere means half a sphere. So if we ever see those, we just want 1/2 times this. And we want this to be diameter of 30.3. And they're being a little bit extra here. So 30.3 over 2 is 15.15. We're just going to have to go with that. 7282.76 rounds to 8. Hemisphere is just half of a sphere, so we cut that in half. Same deal for this one, except for we're dealing with radius, so 26.7 is where we're going. Round it. Unintended. This one doesn't worry about hemisphere. We're just dealing spheres here. So we're going to not worry about that 1/2 part. Radius is 6.4, so we don't have to cut that in half either. It's not diameter, so 1098.06 rounds to 1. Hemisphere with a radius of 4.9. Don't need to cut the radius in half, but we do need to cut the volume in half because, remember, hemisphere. There you go. 246.40 rounds to just the 4. Boom, nailed it. And finally, we are just going to go ahead and call that done. The only thing we're missing is some of the step through on the rectangular prism ones, but those are literally self-explanatory, as they in fact explain themselves. So I'm going to let y'all have a wonderful day, and hope y'all do well in the rest of your classes. Adios, y'all.